Hello, everyone. Welcome and thank you for coming. Today I'm going to talk, and today I am going to talk about powering the front end with React, GraphQL and Relay. I will share a way to build applications that scale from the day one. My name is Martin Artola. I work as a front-end engineer in Swiss Life, a leading provider of pensions and financial solutions, where I help different teams to build and ship world-class applications. By the way, I have been coding and contributing to open source for a very long time, over 30 years already. But before we get started, I will give this a little bit of context. Once upon a time, we were building websites, simple websites. The web was all about sharing text, people links, a few images, and nothing else. But as things were evolving, mostly technologies were evolving, becoming every time more important, also did our collective mindset of what made good business sense. And we started to build web apps, what we call usually single-page applications. If you were coding in those days, you will recognize some of these names. I have a very long list here, but surely you can add more. Backbone, Ember, Knockout, Meteor, CanJS, Dojo, Marionette, Platform.js, AngularJS, JavaScript MVC, Pure MVC, and so forth. I worked in several of them over time. There were a ton of frameworks. Most of them were MVC-alike frameworks, or MVC-alike implementations. All of them were looking how to structure JavaScript applications. But the code bases were growing. We were requiring every time more and more to these single-page applications. And then we started to struggle with that. Applications started to become very complicated and unpredictable. In that moment, we knew somehow that we need to re-architect the way that we build UIs, right? And fundamentally, we need to make it a lot more simple. At that moment, the things began to change, right? Let's introduce React in this path, right? React is a JavaScript library for building user interfaces. It was developed by Meta. Meta is Facebook. I will use one of them over time. And it was publicly released in 2013. And this week did 9 years already, okay? From the public release. That means that Meta was using it even before. I need to here say a big thanks and do a mention to the people that did this possible, right? Tom Okino, Jordan Walker, Pete Hunt, among many other contributors of that times, and even, but not less, Dan Abramov that continue pushing the limits of this library. React was all about rethinking best practices, and its declarative approach to do the things changes the way that we structure our JavaScript applications nowadays. Let's explore some traits of these React applications to understand what it means. A React component is a building block for our UIs. These components are loosely coupled one to the other. Imagine like Lego blocks. We have a lot of them in different shapes and colors, and we can still build and play with them because they satisfy a common API that allows us to do that. Components help us to separate concerns, not in the way that we were doing before at that time, so 10 or 15 years ago, that we were separating HTML, CSS, and JavaScript, else that we started to separate business logic from presentation logic. Components are reusable pieces of UI. It is simple to understand this when we see a button, how many times it's in our application. Components are built of just regular JavaScript. And as you know, JavaScript is one of the most used languages, and it is just listed after English. Components are idempotent functions that describe the UI at any point in time. Given some state, this works, given some state, we can derive that UI, that view. In general, we call this state props, okay? Given some props, we can derive our UI. In this example, this is a hello world component, very simple. We can see how simple it is to create a component and how easy it is to use it. If you are a front-end guy, okay, this is trivial, right? But this, we will see how this fits in the whole story, right? Here we have an enhanced version of the component where just changing a little bit the API allows us to pass a property and get a different outcome. Components are unit testable as they are just JavaScript functions, are easy to test, are JavaScript functions that return markup, and then we test that thing. React is all about composition. We build components from other components because one characteristic is that components are composable. In algebra, if we have f and g, that like two functions, we read this like f composed with g or f after g. And we can compose these functions as long as the output of one function match the expectations of the input of the next one. We can use props to define the API of the components. A little bit we showed before, these props that we derive to state. And it is very common to include a property, define a property that is called children, like in this example, right? We have an app component with a bunch of children. And each of these children, at the same time, will contain other components inside. Now we know that we have different platforms. Each of them has a different look and feel, capabilities, and even constraints. And as front-end developers, we must deliver the best user experience for each of them. For example, we have web, mobile, Windows, macOS, and even TV devices. With React, we can build applications for any of these platforms without knowing the underlying technology, like Kotlin, Java, Objective-C, or Swift. It doesn't mean that you don't need to know anything else, but you will be mostly able to do a good job with not so much training. In this example, we can appreciate how similar are writing a component for the web, like writing a component for native. Mostly what we do is train a little bit, a few days, a few weeks, whatever, just to understand what are the differences between one and the other, and we are able to start to create applications for all of them. Now, let's go directly to do some coding, right? This is, again, I repeat, this is trivial. It's just to show that things works. We have here a normal JavaScript application. This is done with Next.js, just to make it simple. All the setup is a Next.js application. And here we have a component that in this moment render nothing, right? And easily we can write here our hello world, right? And we can see that that is the outcome. We can enhance this component as we were showing before, adding here a property and even defining here the default value. And now we can interpolate it here, right? This, again, I repeat, don't desperate, is trivial for us, okay? Okay, then this is super trivial, it's a hello world, it's just word that the things are working. But we can do things a little bit more complex, right? For example, here I have not passed the property, and where we use the component, we can start to pass some name, for example, my name, or someone else's name. Look, it's even better. Okay. Now I will remove this, wipe out this information, and we will see a bit more interesting thing. Okay. Okay. Here we have a Hello World application, right? A little bit more complex than what we did before, but now we will go to this endpoint, that is the GitHub endpoint for REST APIs. I am passing some token that is access to my account, and then we will ask to the server for my name. I am logged in now with this token in GitHub, and I can retrieve my name from GitHub. This looks interesting, but the point is like, look how things start to become a little bit complex, right? And remember that we have here, for example, a lot of lines to manage how to fetch from the server, how to, what to do with that response. In this case, it's a JSON string, then we need to convert it in a JSON object. And even we need to handle some kind of error, right? And that probably is not the best, but if we have an error, this is what will happen. But what is interesting, probably for what we'll continue later, is that what happens when we do these calls, right? I will refresh my screen here, but now we have here the tools, right? Then we can see that there is a call to the GitHub API, and that is what happened. The GitHub API give me all this information. Really, I was interested in my name that is among all these properties somewhere there, but also I got all this stuff, right? And then remember very well this point, because this will continue in our talk, because will be the next point, the kickoff for GraphQL, right? Then remember that I want just the name, but I got this thing. We say usually like this, right? I want a banana, but I get a monkey and also the whole jungle behind. Good. And the example can be more complex. If you are a React guy, like here I have a version that say, okay, what happens if the component is mounted? Then we need to have an abort controller. We need to stop that call that we are doing there. Else we will have problems. We will have memory leaks and so on, right? And this is just the tip of the iceberg. Even this is a naive approach, right? Then let's think that this is finished. Let's move to the next one, right? Then our components are able to derive the UI, what we see in the screen, right? What we see in our devices from this state or props, okay? But usually that means also going somewhere for that information, right? Then we have been doing this with REST APIs. These REST APIs, like we were looking here, this GitHub REST API has very well-known limitations, right? And mainly two of them are underfetching and overfetching. Let's start by overfetching. Overfetching is what we saw here. I want the name, but I got back the whole jungle, right? We are getting a lot more than what we need. And that means two things, right? We are getting more information, more transport, and this takes longer, right? And the other is underfetching. We did not see before here, but that means when we make a call and we don't get all the information that we need, maybe we get some IDs, and then we need to go back to another REST API to get more data. To solve this problem, to overcome this problem, there were mainly, over time, two approaches: experience APIs or BFS, backend for frontend. Let's talk, for example, they are different technology differently between them, but work more or less in the same way for the backend for the front-end part. What they do is like saying, okay, if you will need the name, I will create an endpoint where you get the name. That means that they start to match what we need in the front. This is very well and works very well when we have a very small application, one developer, one is the same guy backend and frontend, then it's very easy probably to keep track of that things. But the things are not scaling so well when we have hundreds of developers. When we have more than one client, maybe we have a desktop application, a mobile application. In the desktop application, we show 20 fields, but in the mobile application, just 4. Then we need to start to do a lot of things. But also the mobile applications, they the user can have it longer than the website that just need to make a file to get a new version, right? That means that we need to also version them and keep them over time. It's very difficult to maintain, has few flexibility, and creates mostly bad user or developer experience. At that point, I think that experiencing this problem, not only me, the people from Meta came with the idea of GraphQL. Okay. What is GraphQL? GraphQL is a query language for your API. It was developed by Meta. It was publicly released in 2015. Then in 2019 was moved into the GraphQL Foundation. That means that it's not, nowadays it's not a Facebook scene, else it's part of the foundation where a lot of companies belong. Here I need to say again, big thanks and do a mention to the co-creators, Lee Byron, Dan Schaffer, and Nick Schrock, among many other contributors, but that are the original creators of this GraphQL language. Then GraphQL stands for Graph Query Language, but it is not a query language as we could understand SQL, a query language for getting data from a database. It is rather a way to define how we communicate from the client to the server. Due to the fact that GraphQL is defined by an open standard, has not a public implementation, has not an official implementation. You can create your implementation in any language, and then you can do whatever you want with that. You can use any kind of database. It's not necessary that, oh, I need to have a graph database because it's a GraphQL. No, doesn't matter. You can use whatever you want and support any kind of clients. Okay, clients can be written also in many different languages, as long as you follow the specifications, the rules that are in the specification. Let's explore some traits of this GraphQL. GraphQL ships the contract between the client and the server. The clients have the power to require what they want and get exactly that from the server. Nothing more, nothing less, which leads to a better user experience, especially in a slow network connection. The GraphQL schema, here we can see one, represents your business model. This is your business model written in a schema in terms of types and fields, against which you can perform queries. Queries are mostly a way to specify fields that are exposed in that schema. You can see here, for example, in this query, we are requiring for the active user the name. And the response of the server mimic the shape of the query. In this other, I added a couple more of fields, and we can see that the server responds exactly with that information. And again, mimics exactly the same shape of the query. Then, while typical REST APIs you are required to load multiple endpoints, multiple URLs, with GraphQL you can get everything in a single request. Reducing the numbers of calls saves time and money, right? Saves time and bandwidth, especially in a slow network connection. GraphQL queries access to properties that can be deep nested. For example, in this case, we have the name like we saw before, but also we are requiring the notifications that user can have. Imagine kind of inbox messages. And all of them are coming in just one single request. Usually this, before we were doing 2 calls to get this thing. First, to get the ID of the user, second call to get the notification, because each of them are different resources, right? Here we get everything in one single call. GraphQL continues to evolve because the community is growing every day, and the new capabilities are added. In general, they are added like directives. For example, between the last one, we got differ and stream. But let's take a look to the core of GraphQL. Okay. Developer tools like code intelligence, like compilers, like clients, usually maybe you know GraphQL, but today we will talk a lot about BCP, Banana K-pop, are possible because they leverage the type system. Through GraphQL introspection, we can get the information from the schema, and with this information, generate documentation and reach IDEs. Again, you will see that BCP use this introspection to create a lot of information. In general, and this is part of these core capabilities of the GraphQL, fields are nullable by default. This is very important because GraphQL is a networked service. And at any networked service, there are a lot of problems that can happen in a connection, right? Because this networked service is backed by databases, by other services, and then a lot of things can go awry. And it's much better to return null in a field that totally failed the request. While there is nothing about versioning GraphQL like any other REST API, in general, you can totally avoid to do this. You can add new capabilities by adding new types and new fields without creating a breaking change. That means that you continue to evolve the schema without need for versioning. GraphQL defined different operations to communicate with the graph. We have mainly this comparison. You can see probably in REST you get it very easy. But in GraphQL, apart from the queries, that is the way to retrieve data, of the mutations that are a little bit strange because we can do two things. We can change data, but also at the same time, in the same call, we can get information about the results. Until that point, mostly we match the REST API, but we also have subscriptions. Subscriptions are used to listen real-time events coming from our server. There is no equivalence in REST API. Now I will show you a little bit of code, okay? Let's start with, first I will introduce you because as you will know, I would like to say which tools we are using. Here you can see this Chili Cream platform, okay? The Chili Cream team creates a lot of tools for the GraphQL ecosystem. Today we will be using especially some of them. Here you can see how the Chili Cream has been doing a lot of things. I think that is very important for you. Maybe you know them better than me because this is very important for .NET guys, right? The hot chocolate server that we can see here is a .NET implementation. If you are not using it today in production or if you are not using it in your company at all, but you want to test GraphQL, you can spin up a GraphQL server in a couple of minutes. And I find that awesome. But apart from that, we will see other tools, and we will use this one, apart from the BCP from Hot Chocolate, that is the server, that we are using now in a backend that is already running in Hot Chocolate. We will be using a lot this Banana K-pop. Banana K-pop is a GraphQL client, and me, like developer, I use it a lot to make my queries and to get information from the GraphQL server, right? And if you are a .NET guy again, you will have also Strawberry Shake, that is a tool to create a .NET client. Okay, that's it. This is BCP, okay? Sorry, this letter is a little bit small. I hope that you can see, but anything is very simple. This is the query that we saw before, right? And in this query, I am asking for the name, right? Then we do the query to the server, and this is the answer that we get. You can see that mimic the shape of the query. How is this possible, right? This is possible because here in the configurations, I said, okay, I will use this backend server. It's a GraphQL server running in this endpoint. And I also got all the schema. The tool is automatically syncing with the schema and grabbing the schema. And among the operations that I can do, there are a lot, because this server is a real example of a server. We can see this one that is what we are looking now. I can ask for the me, I can ask that is of type user, and for that I can get the name. But also we can get other information. We saw before maybe the display name or the notification. Okay, all this information is visible. See, here you can see that in different ways. There is a lot of information. All these come from the schema. This is very nice because we can see that the tool itself documents everything. Then if I want to here, for example, ask for the display name, I just need to add it, and you can see that I have IntelliSense, code completion, and so on, right? And there I got it back, right? But also it's possible to, for example, do things like ask for the image, right? I want to get the image for my profile, for my avatar, right? And you can see that I have not an image there in my avatar. Then here I will do a mutation in this moment. And what we will do is like, we can set the display name, for example, my name. I could change it, for example, for Martin in uppercase. And I could also add, for example, here an image. And this image will be this photo that I have here. My examples. Okay. Then we do this mutation, and the server should get it back, this information. So that goes. Yeah, that's it. This is a little bit strange because here we did something. Yeah, it's a little bit slow. Internet is not going the best. But you can see that I did a mutation and the display name changed to uppercase. That is because I did a change, and at the same time I can query by the results. And I can see the result of this operation. Also, another thing that is a little bit strange, let's say, or incredible, like I can even upload files. That is, we can do this even with the GraphQL. Then the server got this image and return me the URL and then store it there. This is a nice thing because in the web, especially in the front end, for us, it's nice to have this URL because we can long-term cache them, right? But this is about the capabilities that we have for something so simple. Now, I will go back to the presentation. I will show you something a little bit more complex, let's say. This is an application that we are creating. It's a real application. We call it the crypto application that we create in the workshops. In the workshops, we run a full-fledged application, backend and front, okay? And we create this application with a lot of views. One is this view. That is the dashboard view. And you can see, like front end, what we do here is identify the components that have data. The others around are just for presentation only, right? Just to play with the application. And these are showing a lot of lists of currencies. And then we identify that, for example, these lists are full of list items, and each of these items are rendered in different way. In one place, they are just showing in the ticker, like in the top. Maybe you can see here. This is called a ticker. And in the other, they are showing like charts, for example, right? But are a lot of lists of items. And what is important that each of these components, in each of these areas in red, has different data requirements. For example, in the first one, in the ticker, we want to show there the 10 cryptocurrencies sorted by market cap. In the second one, we pre-select 3 of them, for example, Bitcoin and a couple more. And in the other, we want to get 5 top selected gainers or losers of the day. Then the thing is like we need to create a way, we need to create a query to get all that information. Imagine how many calls you need to do in REST APIs to do these kind of things, and what can be the flexibility to do it. Okay, let's try to create that. This is a long query. I will explain to you what it is, how we build it. Okay, this is just copy-paste from what we did in the workshop, but you can do it here. We will need like 10 minutes to do it. Then you can see We have a dashboard container. This is a component. This is like grabbing all the queries that we need for each part. We have the ticker, we have the feature, these 3 Bitcoin and 2 more, and we have that spotlights, that gainers and losers of the day. Each of them is a fragment. We will see that these fragments are a way that a component has to define the data dependency. And what we do is split these fragments in a way to compose these queries, and that is what I did here. Let's start, for example, for the ticker. Look, I open the ticker fragment that we can see here, matching, and look this thing. I can be very expressive here and say, I want a list of assets are these currencies. I want the first 10 ordered by market cap ascending. All of that I can do it there, right? Plus, we have more fragments inside. These list items are each one of them saying exactly which data they need. For example, they need, let's see, this one, this ticker. They need, for example, to have the symbol and the color, because each one rendering in a different color, plus the price and the percent unchanged and these kind of things. And the same we did for the next groups, right? For example, this feature, these 3 selected, we say, okay, give me the list of assets, just matching Bitcoin, Cardano, and Algorand, that are these 3 currencies, and we did exactly again the same. And we composed it again, fragment and fragments. Each of them say exactly what they need. For example, for that, now we will see again back to the application, then you will remember it. We need to make the change, the charts, and the charts require historical data. That is what we require here. Each chart has around 200 or 300 points, and that's we query for each of these currencies. And we have the same for gainers and losers, that are these ones that we have here. Imagine gainers and losers are more or less the same thing, but we select different data. But again, look, give me the first 5 selected in exactly this way, sorted in this other way, right? And the point is, like when we execute this query, we get all this back in just a single call. And I think that this is awesome, right? We got a lot of data, and all these points are how we make these charts, and we can get this in one single call. Really, we did one single call, then we collected a huge information for our view. In general, most of the views are just one single call, right? But we can do a lot more, right? For example, not all the data is so important. We want to have the ticker on top as fast as possible. We want to have the chart as fast as possible. But the losers that are probably outside of the viewport are not so important to have it so fast, right? Then we have mostly this need to have it top down. Okay, we have these directives in the language, in GraphQL, like differ, that for us from the front end are a kind of hint for the backend. It's like say, you can deprioritize these parts. This is not so important for me. If you can make it fast, the server will define it, maybe send it immediately, but if cannot, or it will take more time, probably will come later. See what happened here, for us was like a single call, right? We did really a single call. But what we get is something a little bit different. Look here, I did it 2 times. Maybe it's better if I just refresh and do it 3rd time. Okay, I got it there. Really, we did one single call when we express exactly what we need for our view, but we got this thing. First, we got a part for the top where we have the ticker with all the information for the ticker. And later, the server sent it some milliseconds later, could be maybe 200-300 milliseconds or 2 seconds later, it started to send the other parts. You can see that gainers or losers in this part, they were not there. That means that we received this in different times. And later on, we started to receive these gainers, and later we received the losers. Okay? And again, we did all of this with just a single query, right? And that is starting to show the power that we have to create data-driven applications, especially for enterprise. Okay, that said, we will move a little bit more. And I will go back to the presentation. Then, as I said a couple of times, it was not intentional. I say GraphQL is awesome, and here I need to say again the same. And I really think that thing, right? When I saw GraphQL for first time some years ago, I had this problem with the REST endpoint so much with the backend guys. And when I say, oh, we can do this thing, this solve all our problems, I mean, right? Then this is the thing, GraphQL give us a lot, much better developer experience. Then, as we could use, as you can say, GraphQL is about sending a query to the server, and the same server will answer with that data. In the front end, we could do that using just a fetch, right? As I did in a nice way to fetch from the GitHub API. But that will not scale, right? That is not what we want for data-driven application when we need to do this hundreds of times. Then we can do it a lot easier, right? We can do it faster, easier, and much simpler. In that point, we introduce Relay, okay? Relay is a GraphQL client that scales with you, as they say. Also, it's a meta project. It was publicly released in 2015. And there are a lot of contributors there. I want to mention just Jan Kassen, because I do a lot of work with him, Andriy Lunyov, because the same, and Joy Sabona, that is like leading the team and doing a lot of stuff there. Then Relay is a JavaScript framework for fetching data from GraphQL. And it is for client applications, right? It combines two things: a declarative approach to declare the data that we need in our components, plus a build step, right? An static optimization. Then what we do is our component define exactly the information that we want, but we will compile this code and we will optimize that query. We will validate them, we will do other stuff, and then we are sure that when we execute the query is valid and also is optimized for runtime. Let's explore some of these traits of Relay. Then Relay makes, as I said, data fetching very easy. It has an incremental compiler written in Rust. It's super fast, super fast. It was even the JavaScript one with tens, hundreds, or thousands of components is really fast. We have, I think, that thousands of components, and we can see a couple of seconds just in Rust implementation for our scale. Components declare the dependencies that they need, and it's Relay who will fetch that data and will pass into the component. Also will be in charge of doing this in an optimized way and avoid to render the component if it is not necessary. Furthermore, there is one more thing. Even if we have a lot of components in our view that share the same query, each component can only access the data that they require. This is called data masking. Okay? This is a characteristic of Relay. Even if in our query we query for 20 or 30 or 100 of fields, our component will just be able to get that few fields that they need and cannot see the others. Then Relay is doing all this heavy lifting for us, is compiling for us, and is pre-computing for us. Let's see this thing, for example. This is when we know very well that in general our applications are bundled. Webpack is doing that, for example. That means that the application artifact is not changing once that we deliver that artifact. That means that we can do a lot of optimizations in that build step and avoid to do that in the runtime, especially if we think that our consumer will have low-end devices, right? But even I believe that even if we think that our customer will have high-end devices, it makes no sense to do this in the hand of our user. It will take a lot of milliseconds that we need for something else. Then Relay keeps all the components updated, and this is doing it more or less in this way that we can see here, okay? When we make a query to the server, this query is normalized and goes into a store. What is interesting of this store that the components are subscribed to changes in the store and for the field that they are using. That means that if the field is changing in the store, then that component will re-render. The other components will not re-render. Then one thing that is important for us like developers is this work faster, right? And we can do it easily if we know that we have type safety behind. Relay can compile out of the box using the Relay compiler, can output or not typing if you don't want at all, or you can output TypeScript types or float types. It's up to you what you want to use. But one important thing is like to get the best of Relay, you need to use a server that sticks to the best practices. In general, GraphQL defines some best practices, and your server should fulfill that practices. That is the case of Hot Chocolate, a server that will fulfill that best practices because they are baked in the server. Okay, here we talked before and we saw even in the examples how we define fragments, right? Fragments is a contract that we have between the component and the API, right? Our component defines there the data requirement. We can see here how we do it. We saw before when I showed in BCP how we did it, right? We have usually a data container, right? A component container, like we did in Redux many times, right? That will collect all the fragments that we need. But now when we look into our component, each component will use this hook, use fragment, to define the data requirement. Did you see that long query that I did before was just a copy-paste of this fragment that we have here. That means that we are collocating the data requirements to the component. That makes very easy to see what we need, where we need it, right? Very easy for us to find that if this symbol is here defined, it's because below, few lines below, we are using it. If it is not, we should just remove it. That it makes very easy to maintain our component. We can think in abstraction. We can just look into our component. Doesn't matter what is happening in other parts of the application. This is also another thing about the best practices, okay? Relay provides first-class support for cursor pagination. This is it's called GraphQL connections, are a model for representing lists of data, so they can easily be paginated in any direction. Also can contain rich information about what is in the connection. I think that is very difficult to see here, but if we have a list of friends, that connection could contain information about since when I am friend of that person, right? That kind of information can be in the connection. This is something very specific for Relay. We have these kind of unique IDs that provide a way for caching the data and also for refetching the data. Okay, these are necessary to be there. When we receive data from the server, we use that global IDs to normalize the data. If we receive, for example, in the first call for my user, just the name, and in another I receive the display name, we can merge these in the same object in the memory because they have the same ID behind. And here we can see how this works. This is mostly for the backend part, let's say. Any type that use the node interface, then will use this global identification and will allow this refetching. Okay, now I would like to show you the second part of this application, this real world application, this is what we will do now. This is the application. We will put it there now on. We will see that. Here we click in one of these currencies, for example, Bitcoin, take care, this price was weak. It's a real price, but we did it like 2 months ago. Don't run now to sell because it will not be the moment. Yeah, then if you click in one of the cryptocurrencies, you can see this other view, right? That we call viewer, and you can see information about the cryptocurrency. Most of the information that we see here, we did like before, I did separate the data, components, each of these are blocks are components. Most of them are key value pairs. I can show here that we have a lot of key value pairs, which has presentation for them. We have a lot of these components. But we have a little bit more of activity here, okay? Anyway, you can see how we make this view collecting all the data that we need, right? Then you can see here again, we have these data requirements. In the header, apart from showing the logo, the name of the currency, the symbol of the currency, we have 2 mutations. I will show just this one, that is the star, right? That is a mutation to add and remove from the watch list, kind of like a button, right? But we add or remove this currency from our watch list. And in the second part, we have this, that is the snapshot that is showing the price activity and also the chart where we can select the time span and the chart will change. The rest of the components, and can be a lot more, right? We did just for example, are just presentational data. We have key value pairs and we do something with them, right? Then let's do that application. First, I will stop the other. Then I can use the same port. And here I have this application also running in Next.js. I use Next.js just to make it simpler, right? And a little bit cool. But you can use Create React app or do it by yourself as you want. I am looking into the component that we have here. Now, this is what we saw before, just because we were looking at data that we were collecting, but we did not see the application working. Okay, that was the ticker that goes there around, and here we have the chart information, and yeah, a lot of cards and so on, right? Now the point is, like when I click in one of them, like Bitcoin, then we see information about that one, and that is what we want to build now, right? Then, as I say before, we have this information on top where we are interested in the mutation, and we have a little bit of activity here, plus all the other parts that are just key value pairs to present. Then, I will start by the index of the viewer. This is, if you do React, you surely get it. This is, we are using here React 18, experimental version even, right? But more or less what we saw here will work in any React version, 18. Then we are using, for example, this error boundary is a way that will allow us, if there is, for example, an error in the network connection, we could automatically retry, for example. Then we put some logic in that component, right? Or we can just show a toast to the user and say, do you want to retry it? Or, oh, we cannot do it later, come later. You know, we cannot do it now, come later. The other is have this suspense boundary, right? Then what we are doing here is saying, okay, as long as we are retrieving the data for the view, show this activity indicator. That is my fallback. This activity indicator is a little bit smart, will not show up, will not be visible for 300 or 400 milliseconds, right? In that way, we don't get a flaky screen, right? Then if it is taking longer, then we will start to see the indicator. And then we have this container, okay, this container component that collects all the data needs. Let's look a little bit at that. You can see I did exactly the same that I did in the other. This container component collects all the information that needs for the header. For example, we need the symbol, the color, the name of the currency, and so on and so forth, right? And then we have the snapshot information, the snapshot fragment. That is another component. Now we will go deep into that. Okay. Here at this level, what we do is just spread the fragments into, we compose the fragments into the parent query, right? And that's it. The UI is, you can see, it's on a stack where we stack the different parts. Okay. Then let's take a look, for example, to the header. You can see I collapsed here a little bit just to show now. You can see this fragment for the header is saying exactly, okay, for this component, I need to have the symbol, I need to have the name, I need to have the image URL. I want to know if this is already in my watch list or not. Then we can paint this like selected or not already, right? And okay, this alert is for the other button that I am not showing exactly now, right? And the same we do with the other parts, especially this one, a snapshot, that is all this area that we have here, okay? We have data requirements. Each of them, you can see we require exactly what we need for our component, right? Then let's look two things. One is like how we do this mutation to add or remove from the watch list. Then in the header, we can see that there is add to the watch list. This is a hook. And there is one remove from the watch list. One thing of GraphQL is that our operations are not something like delete, patch, or so on, are more semantic, okay? We can exactly say exactly what we are doing, okay? Then you can see here, for example, in add to the watch list, we are performing that mutation exactly as I did before with the other, right? We have a mutation operation. And then we pass a variable with the value of the currency that we want, this input that we have there, the currency that we want to add or remove from the watch. Where we use it, here below, we can see that. What I do is like say, okay, if it is in the watch list, remove it. If it's not there, add it, right? I pass here, just to make it simple, I pass the whole asset object, but we are interested mainly in one or two fields there to do this operation. Then when I click in the button, what we do there, we can see that we add or we remove. The thing that we see is like there is a fast response, right? And this is not exactly like this. Let's say the response is fast, that's for sure. But it's not happening so fast, especially from the server side point of view, right? Then you can see when I click, there is a request to the server, and this request is taking even some milliseconds, right? 300 milliseconds or 200 milliseconds, but could take even longer. What we did here is we do an optimistic update, okay? Then we put into the store the information that will come from the server. In that way, we get a fast answer for the user while we are performing this in the backend, okay? This worked very well for these cases, right? For example, putting a like button in a message, something that is not so important up to some point, right? I will take more care if I am transferring some millions to someone in some bank account, because probably we want to be sure that that happened, okay? But in general, for trivial things like this could be enough. And even probably the user doesn't need to know what is ongoing. What could happen if I put in a like in a message? Kim Kardashian gets one less than 25 million. I mean, will not care so much. Then the point is like, we can probably store that information in local storage and retry this several times before showing to the user that there was something wrong, right? And probably during that time we solved the problem, and then the user is not even aware, right? In other contexts, in business, I will say bank transfer, things more important. We probably will block the UI in that point, and we will wait for an answer. We will put a nice spinner. We are doing your transaction, wait a moment until we get proper confirmation from the server, right? But we have this possibility to do it. We can do one thing, we can do the other, we can just wait, put on a spinner and do whatever we want. Okay, the other thing that I want to show in this screen is how we do this chart, okay? in one hand, I did the chart even in DC3. I did my own version of the chart, but it's just on top of D3, okay? But that is the presentation part that we know how to do, or you use HighCharts or any other library. The nice thing here is like when we query for a different time span, because this chart has 200 or 300 points, we need to say day by day or timestamp by timestamp exactly what was the value in that moment, right? And this is a lot of data. Then when we render the first time, we are just showing for 1 day span the values, and this creates my chart. If the user clicks a different time span, for example, 1 week, in that moment we go to the server, we come with the data, and then I produce that animation from A to B, okay? That is what we can see here. And let's see, I did already one call. Let's refresh, maybe it will be nicer, because we can see other powers of relay in this construction. I did the first call when I refreshed the page, and we can see that here we got all this information. Now when I click 1 week, we can see that there is another call here ongoing, okay? And we got back the information. And I do 1 month and we get the third call, right? But now if I go back and I click in 1 week, we can see that we have already all that information in our store. We don't need to go to the server. Relay can fulfill our data requirement directly from the store. And that is really interesting, right? I mean, it is up to us how we set the configurations in our queries to do it like this. And we have like different configurations, something like use the store, else goes to the network, or use the store while you are going to the network, but when you get the value from the network, update my component. You need to be careful. My banking application, I have my problem that I see my balance, and it's very nice until change. I mean, and that usually is bad. I mean, then probably I think that guy did it not so well, right? I will prefer to wait longer there, that get a value that will change, right? But in other contexts, you could play with that better, right? Good, then you can see here we have a lot of stuff ongoing, we have a lot of components, and it was easy to do these things. If you are interested in the internals of this thing, especially how we did this mutation in the chart from the front-end point of view, right? This is for front-end guys. We have here, when we perform the change, we use this new API, React 18. It was not possible to do before. We need to do a lot of work to do that. But now we have this possibility, start the transition, then React keeps showing the data that we have until we get the new data. Before we were putting probably in Spinner, probably a placeholder. I think that is much better user experience to do that, especially because the screen is not collapsing, right? That else was flickering a lot, right? And also, we can play a lot with this kind of animation. This is just React 18, and you can use it. Okay, the same that I showed before, because we will run short on time. React 18 has a lot of possibilities. Here we are using React experimental version that is looking forward in React 18, and we can do with differ a lot of different plays. Just to be clear, it is experimental, but React has been using this for 3 years already. That means that it's not so experimental like it looks like. They are using it in production for 3 years with 1 billion users. Then I guess that we can use it too. Okay, but this year they promise that will be cheaper, this thing. Okay, just to finish here, is about, I talked this saying how we can build applications that scale. Now the point is like what means really to be scalable, right? What means this scale, right? Then we have 2 kinds of scales. One that probably, especially backend guys, know how to do it very well. That means about having a system that can handle a growing demand, right? While keeps the same user experience, right? That means that we have more users, more orders, more customers, hot season peak demand, and still our system resists to all of that. That is one kind of being scalable, right? And we know how to do that. horizontally, vertically, more server, more this, more that. That is old-fashioned way. The point that for me is more important, especially when we work with large teams of developers, a lot of changes, a lot of applications, is to have being scalable in the front end in the way that we are able to deliver more features at the same speed, right? Without going every time slower and slower. Our code base continues to grow, and we have still the same time to deliver a feature. Because our code is simple, it's based on known patterns, and it's easy to maintain, right? And that is what we try to do in the front end. And a lot of this is because we choose the right tools. Okay, from my own experience in having working in many companies, but in the last few very huge companies, we saw that leveraging this ecosystem, React plus GraphQL plus Relay, we got really, really a good performance. We got a lot of people speeding up and easily to do. It's easy to get people. I know that you are .NET guys, who are you? But my friends in the backend, my company, the backend is done all in .NET, except the front end because I am there. Okay. If you want to know more, okay, if you are interested to know more, look the Jelly Cream information all about the hot chocolate server, about the BCP client that you can use with any other. Even if you don't use hot chocolate, you can use this like a standalone application with any other GraphQL server. We did it already in Porto, we did it here in Copenhagen. I will do it also in Minnesota, this course with my colleague, Michael Stuyve. He's author of Hot Chocolate, was here just a minute before. And then we will run it in Minnesota, probably in Sydney, okay? If you go to Oslo, by the way, I will not be there. They will do the same thing, but with Maui. Who are you? Then I think that if you are interested, I don't think, probably Minnesota is a little bit far, but next year we will repeat. We have been here this week, 2 days doing it. We have a lot of fun. We have a very nice exchange with the people there, and we are very happy doing that because it's also part of our open source effort to contribute into the community. That's it. That's all. Thank you very much.